Hello, everybody. We are talking, it is Always DNS, how to troubleshoot DNS issues. The reason why is because DNS is so simple in theory, but in reality, it's incredibly complicated and incredibly complex. So much so that we have a haiku about it, and I'll show you the haiku. I am Michael Smith. I am a field CTO for a company called Vercara. It's a brand new company name as of April. We used to be Neustar Security Services for 18 months. Before that, we were part of Neustar. Before that, we were several independent companies, including one called Ultra DNS. And Ultra DNS was one of the first big authoritative DNS servers. So we hold zone information and we resolve host names. It's pretty cool stuff. Now, we'll go through all this stuff. Don't worry about the agenda. So why DNS? Because every interaction on a network starts with some kind of a DNS query, okay? And as a result, we've evolved it over time to be a control plane. So we use it for load balancing and failover between servers. We use it for geographic affinity. So user is in Europe, we give them an IP address of a server inside of Europe. We use it for validating things, right? So DNSSEC or text records that we use to validate who's allowed to send email for a domain. There are tons of different ways that over time we've added to DNS and we abuse it for different purposes. And so it's at the beginning of the conversation. When DNS breaks, everything else breaks. It's really awesome. There's even the old school haiku that's over here on the right side. It's not DNS. Like, oh no, like you make assumptions that DNS is giving you the right answer. And really, that's not necessarily the case. So I want to go through steps, a lot of examples, a lot of interaction on how you can actually troubleshoot your DNS, how you can troubleshoot network issues, and what you can do about it when it's wrong, okay? But first things first, Windows. Everybody in chat, how do you add a Windows machine to a domain? Anybody remember how to do that? Okay, you go into the network settings, you set DNS, right? You set the machine. So say if it's a laptop and you want to connect it to the network, you tell it to use your Active Directory domain controller as your resolver. And then you do the machine join, add to domain, and then you log in with administrator credentials. Okay. So for anything that's a desktop in a Windows environment, all of the DNS traffic goes to Windows, right? To Windows Server and Active Directory, whatever your domain controllers are, okay? Then on the domain controllers, that domain controller acts as a DNS resolver. It has all the host names for everything that's inside of that domain, and it resolves those. And then it has a policy that says, where do I go upstream in order to resolve stuff? Now, the problem that I have with Windows is that Windows out of the box does not come with any troubleshooting tools whatsoever for troubleshooting DNS. And in fact, we teach people, like everybody in the industry does this, we teach people, how do you do a DNS resolution in Windows? Okay. NSLookup is good, right? Like it gives you what the operating system has. Most of the time, though, we teach people to use ping. And ping is abysmal. NSLookup is abysmal. NSLookup just gives you whatever's stored on the computer. I'll go through with where all the failure points are and then how we can actually troubleshoot around it, right? Ping is overused. In fact, I know some DNS people who, like, they give 1 hour presentations on why you shouldn't use ping and what are other tools that are available, okay? But here's the problem I have with Windows is that it doesn't have any good troubleshooting tools. You'll understand what I mean by the end of this entire presentation. Okay, and that's it. I'm done. 2 minutes. Now, we have, if you talk to anybody, first-year IT students, even senior administrators, I had to write a bunch of search engine content for our company website that was, what is DNS? What is a zone? And the book answer is that DNS, or the domain name system, right, is the address book of the internet, right? And they give us this model. So you have your computer down here in the lower left-hand side, and you have a resolver stub. So there's a little service there that says, oh, you would like to resolve a host name. And it forwards that query, which is usually like, who is, www.foo.com. And that goes in a query to a network service that's a resolver. Most of the time, that's your Active Directory domain controller. Okay. It could also be a network service, like it could be running on your firewall. It could be a standalone name server. But from the perspective of this little lowly laptop here, that's a resolver. Then the resolver does this process that we call recursion. So it goes to .com or it goes to the root and says, who is .com? And it gets an IP address answer or a set of IP address answers. Then it goes to .com and says, who is Vercara.com? And gets a set of answers. Then it goes to Vercara.com and says, who is www? And gets an IP address or several IP addresses in response. Okay, so everybody should know this. In reality, it's a lot more complicated, and I'll get there. I'll show you more complicated, but let's talk some basic terminology here first. So a zone is any part of the namespace. So it could be the dot, which is the top level, or what we call the root. It could be a top level domain, so .com, .org, .ru, .su, .foo, .xxx, all of those are top level domains. It could be a domain, so Vercara.com, foo.com, google.com, or it could be a subdomain, so hosting.foo.com, and then inside of that you have host names. Okay, one of the biggest ones that I saw that I worked with on an incident because their domain is broken was www.sec.state.ma.us. And that is the governor's website for the state of Massachusetts. Okay. And their domain is like broken halfway down this chain of subdomains. It's broken. Okay. But any one of those is a zone. Usually a zone is associated with a zone file that has all of the what we call resource records inside of that. Okay. You have an authoritative server, which is a server that holds the zone information. Right? So in our model here, each one of these servers on the right-hand side has a zone. So the dot or the root has the root zone. Okay? The .com has the .com zone. Okay? The authoritative server has a zone file and it answers, and more importantly, the level above it in the hierarchy. In that zone, it has a pointer that tells you which name servers are authoritative for that zone that's underneath of it. Okay. We have a fully qualified domain name. It's a valid DNS name. It could be a domain. It could be a host name, so www.foo.com. That's a fully qualified domain name. It's synonymous with host name for the most part. Okay. A resolver is a network service that receives a query and from a computer on the network. Okay, it might do the full recursion and trace the hierarchy, or it could pass it off to somebody else. That's called a forwarder. So a forwarder is a resolver that receives queries from other resolvers. Okay, we have a recursive query, which is where a machine, and we have a recursive server too. A recursive server receives a query, and then it navigates that entire tree. Okay. We also have an iterative query, which is we already have the answer that's cached. And so we deliver that from cache because, well, we've gotten that answer before. Okay, so we just store it and then we answer. That causes a lot of problems. It also solves a lot of problems. And then at the end, we have root hints, which is the root zone. Most of the recursive servers that are out there have that zone file. They store it locally so that they know how to get to the actual, the root servers. Okay, and you can actually just go look up root hints and you'll find what the contents of that particular zone file is. Okay. There's one thing that I didn't list here, but in every DNS response you get a time to live. And that time to live is specified in seconds. It tells your recursive server, it tells your recursive server or a forwarder or any resolver really how long they can hang on to that answer before it expires. And then after that, they could still continue to serve it if they can't do the recursion. Okay. If that answer has a TTL and it's sitting there in cache, then subsequent queries become an iterative query, and we just deliver it out of cache. Okay. And that cache and the TTL provides us the ability to buffer requests. So if we look back at our model here, we've got multiple laptops that are here. They're all querying the same recursive or resolver that's here. And so the first time we get a request for google.com, we do the full recursion, and then we cache the answer. And then the next time we get a query, we just deliver that cached answer. So it allows us to scale out to multiple computers without overwhelming this hierarchy that's out here. Okay. And it also makes it faster and a bunch of other stuff. But that caching is important because if we have the wrong answer, we'll cache the wrong answer and continue to deliver it, okay, which could be bad. Or if the service changes, so the answer changes, well, we still have the cached answer, so we'll continue to deliver that, and it'll be the wrong answer. Okay. We also have record types. These are the most common ones. 99% of the time, your query is going to be for an A record, which is just an IPv4. Occasionally, you'll see IPv6. CNAME, you won't query for it, but you'll get an answer with the CNAME. It's just a host name or an FQDN that points to another one. Okay. NS, which is really important. Those are the authoritative name servers for a zone. MX is who gets the email for that domain. And then a text record is information. And we use those, it's basically free-form text. We put a bunch of stuff in there. Okay. But the one that you'll get most of the time is this guy up here, which is the IPv4. Okay. All right, moving on. Boom, 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 boom. So when you sit down and you type in, you want to ping something, we'll go back to ping. You want to ping something, that answer could come from 6 different places. Okay? We'll talk about each of these in turn. You've got a file that holds host information. Funny enough, it's called hosts, that just has IP addresses and host names. You've got the operating system cache. So that little stub resolver that's on your operating system can actually store answers. You've got multicast DNS, which is the cause of much bane, but basically it's a broadcast message. You've got a zone file on that resolver or the resolver. So say if it's a domain controller, that domain controller can have zone files that override what the public does. We actually use that for security filtering. There is a facility, a capability, I guess, called RPZ or RPZ, if you're American. And it is a reverse policy zone. So you implement a DNS block list as a zone where you just null route all of the hosts that you want to block. So you say, oh yeah, you want to go to evilsite.ru. Well, that's 127.0.0.1. Right? So it just null routes. It just sends it someplace that doesn't exist. And we have that. Right? Or it could be all of the host names inside of that domain or inside of that Active Directory org, like however you want to see that, like a tree or a forest or whatever. The resolver itself has a cache, so that way it scales out to multiple laptops, desktops, endpoints that query it. And then you also get an answer from Recursion. Okay, different places. Now, where these happen inside of our naive model of recursion, so the Etsy host is here on the desktop. The OS cache is here on the laptop. Multicast DNS is inside of the broadcast domain for that laptop, so it comes across the network, and it's a little bit random. The zone file could be on the resolver here. The resolver cache is here on the resolver, and then there's the entire process of recursion. Okay. It's never that simple. And the reason why is that with the whole idea of resolvers and recursion and forwarders, a lot of times you're nested several deep. Okay. So for example, here I've got the domain controller. I moved a little bit more to the right and I added a forwarder here. That forwarder just receives queries from all the other resolvers that are out there. Okay. So it's an additional layer. You would expect this inside of your home where you have a firewall. That firewall has a resolver that's on it, usually runs a service called DNS mask. And all of your computers send their queries to the firewall. Well, your firewall uses the DNS that's provided by your ISP. And so that ISP's resolver becomes a forwarder for you, where I have Active Directory domain controller, that is your firewall in that DNS mask that's running there. Okay. And so this is the model we're going to work with as we go through and explain all these things. So first thing we want to look at is Etsy hosts. And I have a demo. So really easy. Here I am. I don't know if I have that one. Let me go here. And I'm going to try to type and talk at the same time. Okay. This is and I messed it up. Oh, come on. Okay. There we go. Okay. So Etsy hosts is a file. We can just do cat Etsy hosts, right? And you'll actually see it's just formatted IP address, host name, or IP address. This one's commented out because it's got the hash in front. IP address, host name. You can put multiple in there. So if I buy it, yes, I'm one of those guys. Okay, I come down and I can go boom, google.com, and a google.foo, right? And you can have multiple host names or multiple FQDNs on that line. Okay, and we can do let's do Facebook here. Just uncomment that, right? And so now if I do will dig work for me? Yep, dig. Let me make this easy. Let's do push shirt. We'll talk about dig here in a minute, right? But if I say, okay, dig google.com, I get 192.168.0.1, okay, which is what I have in Etsy hosts. If I go in and I kill that, and I get rid of, okay, right, now I actually get, this is the real IP address of Google for me. Okay, so you can go in and overwrite it. And a lot of times, this isn't my home machine. I just literally installed this Ubuntu VM like an hour ago. But if you look at my home machine, I've got probably 30 different entries in etc hosts. I use it when I want to just set up shortcuts, right? Like just set up shortcuts so I can reach individual host names. B, I do it when I set up a new service. So I set up a new server, say a new web server. I use etc host so that I can get local answers, and I can actually go visit that website even though DNS hasn't been pointed at it yet, or the authoritative hasn't been pointed at it yet. And I use it when DNS is broken. I use etc host to add an entry in order to just get to the service, because something in the path is broken. Use etc host, it'll solve it. Okay. That's quick etc host. Inside of Windows, do I actually have it? I don't have it. It's down. Purge. Oh wow. There is a host file on Windows. It's Windows System 32 etc hosts. I believe there might be another edition in there. You can actually go edit that on a Windows machine, and people don't do it very often, but you can do it. Okay. Yeah, I have it 5 slides up. Really? There we go. Right. So there you go. System 32 drivers. Drivers etc hosts. Okay. And it's just a flat file, exactly the same format as the Unix side. And very important, you have to be a system administrator or root in order to go in and edit the host file. Otherwise, you could direct traffic everywhere, all over, all sorts of places. Okay, cool. Next one, OS cache. OS cache is hard to see. On Windows, you can find it with, what was it? I forget. There are a couple commands. You have to go out and find them. This is not a common thing, but if you just go, pull up a web browser, Google it, right? Flush cache, DNS Windows. There's a service, right? It's ipconfig/flush DNS. Same with Mac OS. There's a crazy, which is sudo DNS cache util flush cache, and then you actually restart the process that does multicast DNS, and then inside of Linux, it gets a little bit more complicated, depending on what service that you have that's actually running as a resolver. Okay. So caches, the best thing to do with cache, and the problem with cache is that if you flush your cache, right, flush your operating system cache, and then you go query and you get a bad answer from your resolver, or you get a bad answer from etc host, you've now poisoned your cache again. Okay, so you still have the bad answer there. So most of the time, you don't just flush your cache unless you can confirm that it's a problem, and then you can come back in and flush the operating system cache. Okay, most of the time, what you want to do is work around your resolver and see, am I getting the same answer locally that I am on my am I getting the same answer locally from my resolver stub that I'm getting from the network? Okay. And so in order to do that, you have to go find what your resolver is. It's really easy on Linux and Mac OS. It's just cat, etc. resolve.conf. Boom. Right. So here, my name server is actually a server daemon on this Ubuntu machine. It's a server daemon that's actually running, and I send all my traffic to it. But then that one has a huge policy that's there. That one's suspicious. The etc. resolve.conf. The Mac OS one is fairly straightforward, right? So here I've got a couple that are IPv6, and then I've got these two right here that are where I send all my queries to. Okay, so getting that helps you because now you can send queries directly to it and bypass your bypass your operating system cache. Compare what you're getting locally with what you're getting via your resolver. Okay, so back on slides. Oh, and in the Windows, it's ipconfig/all, and then that'll give you a stream of output. And then inside of that stream of output, there's a line that says DNS, and it'll point you to whatever your DNS resolvers are on the network. Okay, that's Find Your Resolver demo. Next one is multicast, right? So keep that in mind. Find your resolver now. We'll use it later. Okay. Next one is multicast DNS. Multicast DNS, in most cases, is an abomination, and it is always the problem, unless you're in a small office and you're trying to find your printer. Okay. And what I mean by that is multicast DNS has a lot of names. So it's multicast DNS. It's in the Apple world, it's Bonjour. It's zeroconf, which is the concept of it, or the architecture idea behind it. On Linux, you've got Avahi, which is a service and a set of utilities. You've got DNS services discovery, and you have link local multicast name resolution. Everybody should know LLM&R, because on the Windows world, when you're looking at system hardening, that's one of the things that you turn off. Because basically, mDNS is a broadcast service. So you have to be on the local network inside of the broadcast domain, right? So you have to be like, inside of the same VLAN or on the same switch, sometimes on the same Wi-Fi, sometimes not, depending on if you have client separation. But you broadcast out and you say, hello, I am looking for hostname.local. Okay, so you have a local domain. And then anybody on the network can be like, oh yeah, that's me. Okay. It's fantastically good for locating printers. And it's really relatively good for locating file shares, things that are on your local network, and that's what it's designed for. But it has some limitations. So it's broadcast traffic only. So it's not routable. It is, it doesn't work with Wi-Fi client separation. There's some other cases where it doesn't work. If you connect to the airport Wi-Fi and they don't have client separation, anybody else on the network can be like, oh yeah, I'm, file share, or I'm your local domain controller. So it has some security vulnerabilities into it, so people shut it off. But it's also kind of random when it works and when it doesn't work. Some firewalls will actually go and they will accept multicast DNS and then reflect that to everybody that's on that network, which is a little bit interesting. But mDNS has always been kind of random. But you can actually see mDNS. You can go inside of here inside of Mac OS, you have a tool called DNS SB or SD, which is DNS service discovery, and you can browse. And you can actually see here, I've got an HP LaserJet Pro, and he's on the local domain, and he is using HTTP over TCP. That's the only thing that's here. Inside of Linux, you have a tool called Avahi. And Avahi as Avahi Browse. So that tells you all of the services. So here's the host name. It's what version it is. This is what network device it's on. And then here is the definition of what that service is. And then whether it's what domain it's on. If we control C that, so that is Avahi Browse.a. And then we can add in there -- resolve, which gives us more data, but it also gives us IP addresses. So here's the network we're on, or the network interface. It's IPv4. Here's the name of the computer or the host name. Here you go, the address. There's your IP address. Here's the port, and that is VNC remote access. Why is that there? Okay, I just got scared. Anyway, that's there. In the Windows world, there are a couple tools that you can download that are GUIs that show you all this data, but there isn't any really good way to find what is available via Multicast DNS. Okay, there isn't really a good way to do this. So literally in the Windows world, we go back to pinging things and looking to see what answer we get. Okay. So I'm not very happy with that. So Multicast DNS, you can go into any operating system and disable Multicast DNS. It helps you a lot with troubleshooting. And on Linux, there's a service called Avahi Daemon. You go in and Avahi, where is it? Etc. Avahi? Yep. So there's a avahidaemon.conf in etc. Avahi that you can actually set up a responder. So this server daemon grabs all the multicast DNS and then echoes it back again. So that way you can have it in different multiple network segments, and it'll learn all the multicast DNS and then broadcast it elsewhere. This does have a lot of potential for abuse, for attacking people across your LAN. Okay. Moving on. Then we can't trust our resolver. Okay. And because that resolver is a network service, you could have your regular resolver, you could have a forwarder, you could have a chain of forwarders. You have really no idea what happens once you send that query to your local resolver. And so you need a tool that allows you to do that. There's this really awesome one called Dig. If you have Mac OS, you already have it. It's awesome. I use Dig pretty much every day. In Linux, you can get bind9 utils or DNS utils. You can go whatever flavor of Linux you're on. Just look, how do I install Dig? In Windows, you can install Windows services for Linux, which gives you a Linux, and then you can install Dig. You could get a real operating system. Yes, there is an official Dig. If you go to the Bind website, they have bind9 utilities for Windows, and one of those is Dig. But you're installing a lot of stuff in order to make Dig work, but you could do it. And then in PowerShell, there's resolve DNS name, which is similar, but not the same. Okay. Dig commands, you can dig. If you just use Dig and a host name, it will give you a type A using your local resolver stub. You can give it a server name, so you can send it, or IP address, so you can send a query to a specific machine. I use this all the time. You can TAC T, which sends a particular query type. Short just gives the answer, and trace is an awesome friend. I will show you here in a minute. So here I have, I can do dig like at 8. Maybe I can type .8.8.8.8. Vercara.com, boom, right? And so this gives me a bunch of output. The output here, this is just information about what version of DIG and what was the query that we sent. These are different flags. So were we authoritative? Did we get an authoritative answer? We got one answer. Don't worry too much about this stuff here, the flags. Here's the question section. So this is the question we got, which is we did an A query for Vercara.com. We got an answer. So this is where all the fun comes in. And here we have an A query or an A answer, and we got an IP address, and we got a TTL of 120 seconds. So we'll cache that for 120 seconds. And then down here, it will show us where did we actually get that answer from, what server did we query, and then some query time, and all this stuff that we don't really care about, okay? The parts that we do care about are here in the answer section and in the question section. That tells us what we asked, okay? So we can do like dig -tmx, so show me who gets the mail. So you see the same thing up here, the header stuff. Here is the question. So we asked for the mail exchange, and then we got the mail exchange record for Vercara mail protection outlook.com. So that says that we use Office 365. Okay. And that's got a bigger TTL because you don't change your mail records as frequently. Okay. You can do another one that I do a lot, which is NS, which is show me who the name servers are. And so here we get the question, which is who is the name server. And then I got an answer section. I've got a bunch of name servers that I use. And then we have this additional section, which says here is host name of one name server. And then here's the actual A record for that server. Here's the IPv6 answer. And so it actually breaks it down and gives me the answer. Okay. The last one that we want to do here is plus short, which gives me the short answer. Okay. Now I can do this on the Mac side. So if I say, here is my name server. So I can do, dig at 75.75.75.75 Vercara.com. Right? So I get an answer there. And then I can go back and I can isolate resolvers. Let's use a public resolver. And look and see, did I get the same answer? Okay. You might not always get the same answer. So if I do Akamai.com, CDNs load balance around. So if I do Akamai.com, I get 2340. If I do it at, just kill the resolver and use my local, right? I still get the same, which is good. But you could get the different ones, but then you can actually go in, put that into etc hosts, and see if you get to the right server and you get the right content. Okay, so being able to query different resolvers, so your internal view, from an external view, from a public third party, from another service you set up, that helps you to troubleshoot, are you actually getting the same answer, or are you getting some kind of a cached answer or the wrong answer from a zone file that's inside of your name server, okay, or the inside of your resolver. So that helps you to isolate stuff. Okay, dig demo, we did that. And then the last one, which is recursion, and we are like 5 minutes out. Okay, and the last one, which is recursion, which you can actually find the name server for a domain and then query against it and get the authoritative answer. So here I can do dig -tns Vercara.com, right? And that gives me a name servers, gives me name servers. Now I can go dig at this guy, which is, oh man, I got to do this hotkeys. C, Control V, say www.vercara.com. Boom, right? And so what I'm doing here is I'm asking add an authoritative server. Here's the host name that I want, and I get an answer, right? And I can compare that to what I get from local resolution. I can compare that to what I get from the browser or from the operating system cache, right? So I can do here dig locally, and then I can do it at my network resolver. Bam. Okay. And I get the same answer, which is good. Positive thing. There's also an option inside of dig that is like God level, which is plus trace. And plus trace will do all the recursion for you. So you get a bunch of options here. So here are all the root servers that I queried. Then I queried com, and I got all of these. These are the authoritatives for the .com domain. Then I queried them, and here at some point I got a, where did I get it? I get a referral, oh, because it's the same server. These guys are there. And then I get down to Vercara, and then I get an answer, and here is my answer. So basically that whole process of recursion, when you use plus trace, it will actually trace and do that whole recursion and tell you where the answer came from until it starts at the root, until it gets down to that individual FQDN. So that gives you tons of data so you can look and say, okay, where is this thing going wrong? So let's go back and do my bad boy here, which is www.sec.state.ma.us, which is actually a broken one. And the reason it's broken is because right here, one of these name servers that are authoritative for the domain, one of these doesn't know that it's authoritative for the domain. So it'll give you an error when you go query it, right? But you can see we traced it. And somewhere in here, we got an answer from, where is he at? Somewhere in here, we got an answer from one of these guys. Let's see who's my authoritative. It's in here, but I can't look and talk at the same time. It's complicated. But anyway, okay. So trace is your friend. It tells you everything that you need to know. Okay. There's my demo. I did it. Now, so you found that you're not getting the right answer, right? Why you know that? Because you queried the authoritative for the domain and you got a different answer. What can you do? So number one, just disable mDNS, right? Inside of Mac OS, you disable Bonjour. Inside of Windows, you disable link local multicast name service. Inside of Linux, there's a switch, there's a flat file. It depends on what flavor it is. But most of the time, you can just turn off Avahi, and that will work for you. You can fix your zone file. Okay, so for example, in the case of my secretarystate.ma.us, they actually have name servers that don't know that they're name servers. So they have to go into the zone and remove those name servers. They just made a change. It didn't back out the old ones. But they go fix your zone so that it resolves correctly. Most of us don't run zones, so this doesn't apply to us. Use a different resolver. So move to Google's resolver, move to a different resolver that's maybe not Active Directory. Use your firewall's resolver, okay, because that does recursion directly across the network. Or just use a static entry in etc hosts, overwrite it. If the answer actually changes, your etc hosts will still point to the old answer. So it could break in some way and you go, oh my God. And then you have to go figure it out like, oh yeah, the name changed or the answer changed, and then go fix your Etsy hosts. But if all the resolvers and recursion and all that stuff is broken, Etsy hosts is a failover to get out of that trouble. Okay. Bonus firewall demo. I'm not going to do the full thing here. I'm going to show you where I was broken. So this is actually a slice from my firewall at home, and it's the logs. You can actually see here Sluicebox, which is my home computer, was going to 8.8.8.8, and it was querying against stuff in the .ru top level domain, and my firewall actually blocked it all out. So sometimes if you have a firewall, that firewall is running some kind of IDS, some kind of policy that's there, your firewall might also just be blocking DNS queries. Keep that in mind. That's also something to check. Okay. So in summary, boom, and we're 2 minutes over. Get better tools. Hey, ping doesn't work. Get dig. Get a machine, run a VM, figure out how to get access to dig because it helps you. Learn a couple commands that are there. Isolate subcomponents. Understand where that answer could come from and work your way back towards the authoritative. Or work your way from the authoritative back to your stub resolver. Dig plus trace is awesome. And use Etsy hosts or fix the zone, fix the resolver, fix wherever that answer is coming from. Okay, cool. And that is all that I have. Thank you, folks. Questions, comments, war stories? All righty. Cool. Thank you. And I am going to end this session.